Hey everybody, welcome to Higher Learning Test Prep and our online series Office Hours. Today we're going to be talking about a few questions from the Test 7 practice test of the SAT. Before we get going, just to let you know a little bit about what Office Hours is. This is your opportunity to ask us any questions you want about the SAT. It doesn't matter if you work with us, if you don't, if you work with our sister company, Remote Tutors, if you just have questions about the SAT, it doesn't matter who you are. If you're a student, if you're a college counselor, if you're a parent, if you're a sibling, whatever it is, if you have questions about the SAT, then please ask us and we'll be happy to look at them. So we have a few questions today from one of my current students who was wondering about a few questions we didn't quite get to in our session. So these questions come from, like I said, practice test 7, and this is the calculator part of the math test, and the end of the test where the questions get a little bit difficult. So I'm going to screen share here so you can get my chalkboard through the Hangouts vortex here and out the other side. Here we have number 26. So it's a kind of challenging question, and this is a great example of how I try to use problem solving. So problem solving to me means breaking questions down into smaller pieces. And so I usually, what I do when I do problem solving, when I don't know what else to do on a question, is, obviously, first thing you do is read the actual question. And the question here is, which of the following expresses F in terms of P and C? And of course, that just means get F by itself so that there's another way to express F. You could say F, or you could just say, the correct answer over here, whatever one it is. Right, so that's what it means. Just how do you say F without saying F, right? So these are the ways you could say F. One of them is, I suppose. And when I'm problem solving, what I do is I start with the question itself. And then, so start with the question, obviously. And then I'm going to use answer choices as soon as I can. And as soon as I start with the answers, what I want to do by using the answers is like look for patterns and differences, you might say, but really looking for patterns, similarities, and differences. And then ask yourself small questions. Maybe we should say smaller questions. Sorry for my terrible handwriting. That's the word smaller written in scribbles. Ask smaller questions. So let's see here. I guess to be clear, this question asks something more specific than just F in terms of P and C. It's F in terms of P and C when there is 180 food calories entirely made up of P grams of protein, F of fat, and C of carbohydrates. But I really think it's important to start with a simple, small question, like I did here, this last piece. And when word problems get a little bit more complicated, definitely do that. Okay, so now I'm seeing some similarities, 20s in every single answer. We have this parentheses P plus or minus C, right? And 3 of them say P plus C, which is an indication that probably, not just because there's 3 out of 4, but also because they're going to put correct answers are going to have very closely related incorrect answers. So the likelihood that one of these is A, B, or D is actually stronger than 75%, stronger than 3 out of 4. Doesn't mean I actually don't remember which one's the right answer, but I will say also we have 3 of them that say 4/9, and we have obviously 9/4 and 4/9 are happening in each answer, and then there's negative 4/9 in 2 out of 3 of these. So for all intents and purposes, if you kind of like were to just render a guess at this point, if you were just going to guess randomly, you'd probably say the one that has the most common pieces is B, right? I mean, like we have 4/9, which comes up 3 times. We have negative 4/9, which comes up twice, whereas positive 4/9 only comes up once. And you also have P plus C in 3 answers. So all the things that are different have sort of like converge with the most common components in answer choice B. So that's where, if you're just randomly guessing, where to go. But when after I've looked for these patterns, I ask myself these smaller questions. I start asking myself, well, like, where are the 4s and 9s coming from, and where's the 20 coming from? Right. So, I mean, I don't see any indication about 20, but I do see plenty of 4s and 9s over here in food calories. Right. I know that if you pay super close attention to what the question is asking, you can just figure this out. But sometimes when the questions are coming at you and you're worried about time, you may not totally process that we're talking about food calories, and the 4/9, 9/4 thing lets you know where to go. So we know we're dealing with food calories, and we know we're dealing with these categories right here. And it says 180 food calories come from p grams of protein. Okay, so we have protein, carbs, and fat here. We have energy per gram in the title, and a lot of people forget to read titles. So energy per gram. Okay, so my first move, I'll be totally honest about how I thought about this first time. This first equation I'm going to write isn't right, but what I kind of thought is like, okay, so like P's and F's and C's all got to add up to 180. And you could start there. And you'd be like, well, hold on, wait a second. What are P, F, and C? These are grams, and you can't add up grams to get calories because 180 is calories. So that's another thing about asking yourself smaller questions. Just start figuring some stuff out and ask yourself some smaller questions. Your first equation doesn't have to be your final equation. So of course, this equation isn't totally accurate. What's more accurate to say is like, oh, calories. So you get 4 calories for every P gram of protein, and 9 for every F gram of fat, and 4 for every or a gram of carbohydrate. So 4 calories for every 1 C. And this adds up to 180. Okay, so I don't know what else to do, except I know that in my originals I'm trying to get F by itself. So let's just do that. Like I have this equation. I figured out how to use the 9s and the 4s. I figured out how to like really say that it's really grams times 4, grams times 9, grams times 4 to get calories. Okay, so get F by itself. We'll subtract the pieces. Negative 4P, negative 4C, plus 180. Divide by 9. Aha. Now I can see how I'm going to get that 20. I didn't explicitly ask myself that, but I was wondering because I didn't see it anywhere. So divide every piece by 9. Get positive 20 over here. No answer matches this, so you got to like, looks like every answer tells us to combine P's and C's in parentheses. So let's do that. You might say F equals, you might pull the negative 4/9 out. P plus C, right? Negative 4/9 times both of those, plus 20. Now that's not quite the same order, so now just move them in the right order per the answer choices. Again, just like the answer choices guide you here. 20 minus 4/9 P plus C. Of course, there's other ways to write this, but B ends up being the right answer, and it's useful to notice. It's not always true, but it's important to notice that the answer that had the most in common with the other answer choices is likely to be true, right? So if you're going to guess, that's where you should go to guess. So hopefully that question makes sense to you folks. The most important thing, I guess I'll start screen sharing one more time and we'll jump on to the next question. But before we do, I just want to reiterate back through the vortex here. I just want to reiterate that I'm using answers to help me. I'm looking for patterns and I'm asking myself smaller questions. That's what problem solving is like on this test, right? I mean, that problem solving is, maybe you don't always have multiple choice answers in life, but you're looking for patterns and you ask yourself smaller questions. What's the deal with 4? What's the deal with 9? What does P and C and F stand for here, right? Like you can ask yourself these small questions. Don't feel like you have to, in one fell swoop, get the right answer. And I think that's a problem that happens from the way we're taught how to do things in math class. No offense to math teachers. You guys are doing great work. If you're a math teacher, I commend you. It's just to say that this test is a little bit different than that work that you're used to teaching here. So let's see. I think this is the next thing I wanted to look at. Aha, yes. So this is an interesting question. It's not that bad of a question, but it brings up a point that I see this a lot with students. First of all, I guess I'll start by saying, you know, speaking of breaking things up into smaller pieces, I'm going to draw as best I can 2 triangles here. I know that we're already given these triangles, but you know, what I've noticed is if they give you if they give you a figure with overlapping triangles or triangles flipped around in some weird way, they're probably positioned in a way to make things harder and not easier. The SAT is not going to give you the most convenient way of looking at this because remember, it's not that they're jerks, it's just that they're trying to make a question challenging without making the material very difficult. right? So they don't want the test to be, if you have questions about that, I can elaborate at some point, but suffice to say for now, the material isn't that challenging in terms of skill level. So they try to make questions a little bit more difficult in other ways. So look, I just sort of, you might say, I understood that they were going to make this question more challenging by overlapping these triangles, and I just tried to make it easier on myself by drawing them separately. Okay, and then the biggest misconception has to do with this tan 3/4 thing. I guess before, let me just label some stuff. This is 15 here. dA is 4. Okay, well, that's not really, I guess I'll do this. I'll make a little notch here for a D, so I can say dA is 4 from here to here. Okay, the biggest misconception has to do with what tan B equals 3/4 means. That means that the proportion of side lengths is 3/4. And if you forget that, if you don't remember that that's a proportion thing, you could kind of like start by being like, oh yeah, well, you could start by making the mistake of saying, okay, opposite. Remember, SOHCAHTOA is how you can tell, and write it out so that you don't make a mistake here. It doesn't take long to write out SOHCAHTOA. TOA, so opposite over adjacent. So that means opposite of angle B. Maybe you first start by calling this a 3 and this a 4. But then you would have to say, well, tan B equals 3/4. Why doesn't that work for this big triangle? That's another benefit of having drawn it separately, is that you would have to notice that would mean that like this is 3 and that this is 4. And of course, we know that that's not true for a number of reasons. I mean, like this thing's 4, so the big thing can't be 4. Also, Pythagorean theorem would get violated because 3 squared plus 4 squared does not equal 15 squared. So you would have to notice at that point that this is wrong. What you could say, the correct way of labeling this might be to say, call this 3x, 4x, and try to recognize this as a Pythagorean triple 3, 4, 5. There's a huge, huge benefit of having memorized a couple basic Pythagorean triples. 3, 4, 5, which, as we'll see in this question, they can get bigger, 30, 40, 50, 300, 400, 500, anything. Anything that's a multiple of 3, 4, and 5. The other one that comes up quite a bit on this test is 5, 12, 13, just so you have an idea of your two most important Pythagorean triples. And to be clear, you could multiply each of these by whatever you want. So like 10, 24, 26, which is multiply them all by 2. Or anything else, 50, 120, 130, whatever. So getting back to this problem, 3, 4, and 5x, let's call these just y's. 4y, 3y. And look, here's the key. This is 5y, and we already know what that equals. It's 15. What does that mean? It means our y is 3. Another way of saying that is this thing is a 3, 4, 5 that's been multiplied everything by 3. Scale factor, you could call it if you want as well. Well, if this is 3 times y, it's 3 times 3, which is 9. If this is 4 times y, well, then that's 12. 12. Okay. So that's 12. Now, look, we don't know what BD is, except BD is 12, the whole BA minus this piece 4. So BD over here, which I've labeled as 4x, that's 8. Means x is 2, so everything's falling into place. That means 5 times 2, 10. 3 times 2, 6. Now, all they want to know is the length of DE. We've solved it. It's 6. Right? So there's a benefit. Obviously, there is a benefit of seeing these overlapping and saying, oh, this is 12, and this is 4, so therefore this is 8. But you don't lose that benefit by having drawn it out a second time in 2 separate pieces. You only gain from that. Right? So the biggest thing to know is that trig is proportions. Right? That's the biggest sort of skill set thing. It's not exact values, it's proportions. This wasn't 3, 4, 5. It was 3x, 4x, 5x, and 3y, 4y, 5y. The second biggest thing was Pythagorean triples, 3, 4, 5, 5, 12, 13. And the other piece when it comes to problem solving is just get started if you forget what's going on. Remember, we noticed if we forgot that it was proportions, we could prove that to ourselves because there was no way that this was 4, this was 3, and this was 15. That's one way of saying it. So drawing it out in 2 separate pieces, I suppose, was the other piece there. And that's really something that I do naturally every time now. Right? So trig, Pythagorean triples, knowing that trig is proportions, and then knowing in geometry questions, if you're given a couple overlapping shapes, draw them separately if you can. There's probably a real benefit to doing that. Okay. So let's see. I think I have one more math question here. Let's see. I think this is it. Oh yeah, good one. No, notice this is number 38, folks. So number 38 on a section 4, which is questions 1 through 38. This should be a hard question. It's at the end. The biggest thing I want to notice here is that on a question that feels pretty easy and it's number 38, be careful of language. And the word random is your key word here that you have to be careful about. One way of saying this, I say to students, just because it's memorable, is random is not random. I mean, that doesn't make any sense. What is this dude talking about? What I mean by that is just beware of maybe I can amend this idea and be like, random is not totally random. Especially not on hard question. It could be on number 12 in this section, or even number 20, maybe, but definitely not on the hardest question. Here's the big deal on this question. It says, here's the question itself. If a contestant is selected at random, what is the probability that the selected contestant received a score of 5 on day 2 or 3? Now, if you stopped right there, it would be a simple question. Here's the part that matters. Given that this contestant that we're selecting, supposedly at random, is not of the whole group of 60 or even 20, right? Because they do say up here, no contestant received the same score on 2 different days, so you could maybe think it's out of 20. But this is the key. Given that the contestant receives a score of 5 on 1 of the 3 days, that is, this person is being randomly selected out of this group, and we know they're all different people, different days, right? So I guess I misspoke. Like this 20 would be if you thought someone could have gotten it on different days. Or bottom line is I haven't thought too much about that because it doesn't matter. The important part is a score of 5 at some point. Well, looks like there were 7 scores of 5 since nobody got the same score twice. The person who got it on day 2 or 3, that's 5 people. 2 plus 3, 2 on day 2, 3 on day 3. The odds, if you're picking out of this group of 7 people who got a score of 5, the odds are, the odds of that being a person who scored 5 on day 2 or 3 is actually really high. There's only 2 other people that didn't get a score of 5, or that did get a score on 5 on day 1, right? That didn't receive that score on day 2 or 3, despite the fact that they did get that top score. I know that sounds confusing. That's the point of this question, right? There's 5 people out of 7 people that fit into this category of day 2 or 3 top scores. The fact that it's a score of 5 and there's 5 people, it definitely also adds to the confusion. But 5 sevens equals, I mean, it's just 5 sevens. That's the answer, right? So the big deal is it's not random out of the whole group. So I hope that that's helpful. I know that these questions can be a little tricky at the end, but I want you to notice none of this had to do with like calculus, right? This isn't the hardest math ever. So as long as you did fairly well in, freshman and sophomore math classes, you should be able to do these questions. The biggest thing is giving yourself the right problem-solving tools, the right problem-solving tools, so that you can attack these questions the right way, so that you have the skills to attack these questions in slightly different ways than the average student does. So if we can help you on anything at all, whether it's the SAT or the ACT, any subject within those 2 tests, we'd be happy to. Send us a question. We'd be happy to help, whether you're a parent or a student or a college counselor, whomever you might be. If you're interested in anything about the SAT, this could be big picture or individual questions, or just advice, just let us know. Again, I'm Jeremy Champa from Higher Learning Test Prep, and this is brought to you by Higher Learning Test Prep and RemoteTutors.com. So if you have any questions, feel free to reach out to us on YouTube or email or on the websites, whatever is good. We also teach lessons on Skype, so you could just find us on Skype. Either way, any of the ways is great, and we hope to hear from you. And until then, take care and happy studying. Bye, everybody.